Meteorologists use pressure levels instead of altitude when analyzing the stratosphere, because pressure gives a clearer picture of how the upper atmosphere behaves. During winter, the stratosphere above the North Pole cools down rapidly as soon as the sun drops below the horizon. This extreme cooling creates a strong temperature contrast between the polar region and the warmer air near the equator. That temperature difference forms a powerful ring of fast-moving winds high above the Arctic, known as the polar night jet, which is part of the larger polar vortex. This circular wind pattern acts like a barrier that keeps cold air trapped over the North Pole. However, throughout fall and winter, weather systems from around the globe send atmospheric waves upward, much like ripples spreading across a lake. Most of the time, these waves only cause minor disturbances, but occasionally a strong wave strikes the polar vortex hard enough to weaken it significantly. When that happens, air from other parts of the world gets pushed toward the North Pole. As this extra air piles up in the stratosphere, the pressure increases and the temperature rises sharply. This sudden jump in temperature is what we call a sudden stratospheric warming, or SSW. Once the stratosphere warms, the temperature contrast between the poles and the tropics becomes smaller. That reduction weakens the polar vortex. Sometimes it simply becomes less intense. Sometimes it splits into two separate parts, and in more extreme cases, it shifts away from the pole altogether. In a major SSW, the winds can even reverse direction. Instead of blowing west to east, they blow from east to west. These changes high above the Earth can influence the troposphere below, where our everyday weather occurs. A weakened polar vortex often leads to higher pressure near the Arctic in the lower atmosphere. That can push the jet stream southward, reducing its strength. When this happens, regions like the UK and parts of Europe become more likely to receive colder air from the north or east, instead of warmer air from the Atlantic. But it's not guaranteed. Historically, about 70% of SSW events lead to colder weather in the UK, while 30% do not produce significant impacts. For example, the SSW in January 2019 caused very little change in UK weather, though Scandinavia experienced stronger effects. In contrast, the major SSW of early 2018 triggered the famous Beast from the East, which brought severe cold and snow to Europe. Typically, an SSW happens every couple of years, but a Beast from the East style event is much rarer and tends to appear about once a decade. In the current season, observed stratospheric temperatures have followed the normal pattern for most of the fall. However, an unusually early warming has begun toward the end of November and the beginning of December. Computer model simulations of upper-level winds also indicate a weakening trend. Many of them suggest wind speeds may drop to near zero, which signals a minor SSW, not a full reversal, but still a notable weakening. If this weakening continues, any potential weather effects at the surface typically appear after a delay of roughly 2 weeks. That means any influence on UK weather wouldn't likely show up until the second or third week of December. For now, though, short-term forecasts point toward milder temperatures, with westerly and southwesterly winds bringing conditions warmer than average. Beyond that period, there is still considerable uncertainty. Some models hint at higher pressure developing near the UK later in December, but the signals are inconsistent. It's simply too early to say whether this developing SSW will bring a colder pattern or fade without major effects.